Hello friends, welcome to day 18 of our exciting age journey. I myself Akshat Goyal. So today we are going to discuss about introduction to recurrent neural networks and LSTMs for sequential data. We are going to also discuss about their comparison. If you haven't covered any of the videos, please do click the link in the description and you can watch the full playlist. And please do subscribe to our channel aicodegyan and hit the like button so that you don't miss any day content of the 30-day AI content challenge. So let's start. Hello, so today we are talking about recurrent neural network. So recurrent neural networks are designed for sequence data like text, time series, stock prices, sensor readings and audio signals. It remembers past information using a hidden state. So let us go through the mathematical equation. So if we get one as input, xt as input, ht as hidden state, and w as the weight matrices. So like other neural networks, weights and bias are added with each layer. So we get we can calculate h of t is equal to tan of h, which is the activation function here, and weight of xh into xt plus weight of hh into ht minus 1. And so here ht minus 1 is the memory of the previous hidden state at t minus 1 plus bh. So bh is the bias added at hidden state, yt is the output. So here yt is equal to weight of h y, that means weight from hidden state to output into ht plus by. So basically this is the output here, and so let us understand using the diagram. So take one as input, xt as input, ht as hidden state, and w as the weight matrices. So like other neural networks, weights and bias are added with each layer. So we get we can calculate h of t is equal to tan of u. This is the RNN structure. So suppose we have xt as an input and we have hidden state in the between. So what is going to happen? This output yt will be stored as a memory in the the function, so that it can be stored for the future calculation. So we have xt minus 1, ht minus 1, yt minus 1. So this will be further used for calculation of ht, as we have seen in the equation. So this is the advantage of the recurrent neural networks. Let us understand the disadvantage of RNN. Basically, it struggles with long-term dependencies, and gradients can vanish or explode during backpropagation. So we haven't mentioned the gradient here, but if we calculate a gradient over these different states from past, there is a term called gradient, which we can calculate using calculus. And these gradients are very small, so small gradients are multiplied to give the overall gradient, which leads to vanishing gradient. So this is a big problem which we face in basic RNN. So now let us see how we are going to solve it using LSTM. Let us discuss about LSTM, long short-term memory. So basically it is special type RNN that solves vanishing gradient problem. It maintains long-term memory using cells and gates. So we have three types of gates: forget gate, input gate, and our output gate. And we have our memory state. So takes care of the hidden state and the current state. So how it is going to process is through a forget gate it will process our hidden state, and through input gate it is going to process the current input. So we have the current input xt, we have the input gate it, here we have our sigmoid function, activation function, we have the candidate memory, and here it goes to plus. This will plus both the equations. So let us understand the equation. How it goes: we have the forget gate, which is equal to sigmoid of weight of forget gate into, this is a matrix. So basically this is nearly similar to RNN. How we calculate RNN here, matrix is st minus comma xt is same as wf into st minus 1 plus wf xt into xt plus bf. So here both the hidden state of the memory will be used to calculate the forget gate. Similarly, we are going to use in the input gate. Here only this weight factor and biases would change. So we have this input updated cell state here, so which will determine how we are going to use the forget state, forget gate along with the cell memory state. You can say cell state in past. plus input gate into cell of cell state. You can say it's called as updated cell state, memory cell state. So, and we have the output gate, output of t is equal to sigmoid of weight of output gate and same matrix of st minus 1 comma xt. So this we can see through that this is concept of linear algebra plus p naught. Hidden state we have st is equal to output of t vector dot product of tan of h, which is activation function, into updated cell state ct. So this is how our LSTM works. Now when we do the comparison, so basically we have this short-term memory vanishing gradient issue is resolved using LSTM, but it is present in RNN, normal RNN. So it is more complex, but it is effective than RNN. And for long-term neural networks, or you can say we are going to solve complex problems using LSTM. So thank you. Bye bye. Hello friends. Today we have covered introduction to recurrent neural networks and about LSTM and about the comparison. So I hope you've understood the concept. If you have any doubts, please do put in comments, and you can mail us at aicodegyan@gmail.com. Next, we are going to cover about training deep learning models. So please do subscribe to our channel aicodegyan and hit the like button. Click the bell icon so that you can keep receiving notifications about 30-day AI content challenge, and don't miss anything. Please keep learning AI and let us learn AI together. Thank you. Bye bye.